Today we are doing the second half of P2, which is exponents and radicals. You'll need notebook paper today to take notes. Example number 1, rationalize the denominator. The problem is 5 divided by radical 10. In order to rationalize the denominator, we're going to have to multiply this fraction by radical 10 over radical 10. The numerator is now 5 radical 10. The denominator, radical 10 times radical 10, is radical 100, which is just 10. Next, you'll want to simplify the 5 and the 10. And so your final answer is radical 10 over 2. There is no longer a radical in the denominator, so it is rationalized. Problem number 2. The numerator is 5. The denominator is radical 14 minus 2. Now, in order to rationalize the denominator here, we are going to need to, need to multiply by the conjugate. In this case, the conjugate is going to be negative radical 14 minus 2. The conjugate is always found by taking whatever the radical is and changing the sign. So we're just going to make a note here, change the sign of the radical. Sorry about this. I was trying to resize that and I'm having trouble with it. There we go. Okay, so we change the sign of the radical. We leave the negative 2 alone. That sign does not change. Now, at this point, we need to distribute the 5 in the numerator. So that will give us negative 5 radical 14 minus 10. And then in the denominator, we actually will need to FOIL these two things. So first times first is negative 14. Outside times outside, negative 2 radical 14. Inside times inside, positive 2 radical 14. And negative 2 times negative 2 is a positive 4. The numerator, I'm going to leave alone for right now, negative 5 radical 14 minus 10. The denominator, we have a 0 for the middle terms, and then negative 14 and 4 is negative 10. Now we just have to do some simplifying. So I'm going to factor out this negative 5. That leaves a positive radical 14 and a positive 2. And then in the denominator we have a negative 10. And finally, this negative 5 is going to simplify with the negative 10. We have a 2 left over in the denominator. So we end up with radical 14 plus 2 all over 2. Now, some books may separate this and write it as radical 14 over 2 plus 1. And that would be fine. Either answer is acceptable. Number 3, reduce the index of the radical. If you have something like the 6th root of x to the 3rd power, we are going to reduce the index by rewriting it so our 6 is actually a smaller number. So use the properties that we studied the other day and rewrite this problem as x to the 3/6 power. Remember, the power on the inside here is your numerator and the index is your denominator. Now 3/6 can simplify to 1/2, and then you can put it back into a radical so that you have the square root of x to the first, and now you have reduced the index of the radical. Number 4. This time it's the 4th root of 3x cubed, and the 3x is in parentheses. And then that whole thing is actually to the 4th power, like that. So you're going to end up with 3x to the 3rd, and then all of that is to the 4/4 power. So what happens is when this index is the same as the power out here, they end up just canceling each other out. And the whole thing is 3x to the 3rd power. Example 5, write as a single radical. Here is a big giant radical, and then underneath that you have another radical, and inside that is 243 parenthesis x plus 1 close parenthesis. So when there is no number in the index, we understand that it is assumed to be a 2. And when you have a radical within a radical like this, you simply multiply those two radicals together. So this ends up to be the 4th root of 243 times x plus 1. Now we do need to simplify this a little bit because 243 has a 4th root in it. We can rewrite 243 as 81 times 3. And the 4th root of 81 is 3. So that 3 comes outside from the 81. This 4th root of 81 is 3. And then we still have on the inside the 4th root of 3 times quantity x plus 1. And now we are finished. Another example, giant radical, and then on the inside it's the cube root of 10 a to the 7th power, b to the 1st power. So the first thing we'll do is write these as one radical. Remember, this is actually a 2, so we multiply these. 2 times 3 is 6, and our new problem is the 6th root of 10 a to the 7th, b to the 1st power. 10 does not have a 6th root. However, a to the 7th does. The shortcut here is to take the index and see how many times it will go into the power. It goes in there one time, so we bring out a to the 1st power on the outside of the radical. And then we keep that 6, we keep the 10, we have a to the 1st left over, and b to the 1st is still in there. So what happens is we take 6 into 7, it goes in one time, and the remainder is 1, and the remainder is left over inside the radical. Number 7, the problem says to simplify, and we're going to take 4 radical 27 and subtract radical 75. Now we cannot subtract radicals unless they have the same number underneath the radical. So the first thing we have to do is simplify. 27 can be rewritten as 9 times 3. 75 can be rewritten as 25 times 3. Sorry, that's 25. So we're looking for perfect squares that will divide evenly into 27 and 75. Next, the square root of 9 is 3, so I'll go ahead and do that. And then we still have 3 on the inside. And then the square root of 25 is 5, and we still have 3 inside there. Out here, 4 times 3 is 12. So now we have 12 radical 3 minus 5 radical 3, which we can do. It's kind of like working with like terms. You have to have like radicals in order to do the problem. So 7 radical 3 is the final answer. And our last one, number 8. The numerator is 2.1 times 10 to the 5th power. And all of that is in parentheses. I'm sorry, not yet. Scratch the parentheses. (2.1 times 10 to the 5th power divided by 1.4 times 10 to the 3rd power. All of that is in parentheses squared. So what you're going to do is work these separately. You can do 2.1 over 1.4. You can do that on your calculator if you want to. That ends up to be 1.5. And then 10 to the 5th over 10 to the 3rd. When the bases are the same, you subtract the exponents. So that's going to give you 10 to the 2nd power. And remember, all of that is still squared. Now on your calculator, 1.5 squared is 2.25. And then 10 squared, power to a power you multiply, is 10 to the 4th. And so we have simplified that problem. And that's it.